Let's talk about the future of power infrastructure. The sheer amount of high-performance computing and AI applications these days is forcing engineers throughout the world to face a fundamental engineering hurdle. How can we maximize output capacity and thermal performance while working within increasingly constrained physical footprints? And folks, the answer may lay in a move from legacy CRPS to the M-CRPS standard. And guess what? That's exactly what we're talking about today. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Ian Warner from Bel and I explore why the industry is shifting from legacy CRPS to the M-CRPS standard. How open standard solutions from the Open Compute Project provide superior reliability, intelligent monitoring, and the flexibility needed to power the next generation of data center and networking infrastructure, and how Bel is positioning itself at the forefront of this evolution. And before we get started, don't forget to click that link. There you can find even more information about this topic from Bel. Hi, Ian. Thank you so much for joining me.
Thank you, and it's a pleasure to be with you, Amelia.
Fantastic. Okay, so we're talking about the benefits of M-CRPS for redundant power solutions for embedded applications. But Ian, before we dig into the details, we're looking at a need for greater power levels and densities for today's high-performance computing and AI applications, right?
Yes, that's right, Amelia. For years, users of redundant pluggable power supplies have relied on suppliers and a loosely organized power supply community to offer standard products to meet their diverse needs. While some power standards were developed by way of the Intel CRPS, these products seldom serve the needs of the majority, especially within the networking community. Today's applications, while of course needing the most compact and efficient solutions on the market, also demand greater hold-up times, operating temperature limits, and direct connect cybersecurity protection. The new M-CRPS power standards, the topic of today's discussion, solve many of these emerging needs of today's engineers sourcing standard off-the-shelf power supplies.
All right, so Ian, we're also looking at a big increase in the CRPS server power supply market in the coming years, right?
Absolutely, Amelia. The M-CRPS power supply market is rapidly expanding as data centers transition from legacy CRPS and other unique designs, unconsolidated power supply styles to support the extreme power density requirements of generative AI and high-performance compute. M-CRPS is a newer power standard. It is a primary driver within the broader CRPS server power supply market, which was valued at approximately $1.5 billion in 2024 and is projected to reach well over $2 billion by 2031. This data is a best guess, of course, at the overall market size. The key takeaway is that this market has strong growth projections and users are quickly becoming familiar with the standard.
Ian, I've been hearing a lot about new open standard solutions in this arena. So how do these solutions compare with legacy CRPS?
Legacy CRPS, while defined by Intel, was loosely adhered to. In many cases, CRPS to some producers just meant that they had a power supply that matched the CRPS size. Additionally, the Intel CRPS specification didn't have standards for 54-volt output products. Under M-CRPS, these issues have been corrected. M-CRPS also adds enhanced hold-up times used for vaulting data when a power disturbance occurs. M-CRPS also has wider operating temperatures. The last key feature added with M-CRPS is cybersecurity protection so that unscrupulous folks can't direct connect to the power supply and take a system offline.
That makes sense. So why should we consider moving to M-CRPS?
Just about everyone is moving this direction, needed or not. Engineers are migrating to M-CRPS-based power solutions largely to help with the efficiency and cost savings both on the CapEx and the OpEx side of things. M-CRPS power supplies mainly are produced to meet titanium 96% efficiency, which significantly lowers the operational energy use. M-CRPS power also boasts some of the highest power densities at 120 watts per cubic inch, which means the end design is as compact as it can be, which is great for modern edge computing and AI servers.
So, Ian, what kind of benefits do these solutions bring to the table?
Yeah, Amelia, key benefits of M-CRPS include superior reliability with N plus one redundancy. N plus one redundancy meaning multiple power supplies in use. M-CRPS power supplies also support hot swap usage, allowing for maintenance without interrupting server operation, which reduces downtime. M-CRPS power also offers flexibility design, allowing users to right-size the power supply based on specific server needs, while also supporting various voltage inputs in AC to DC and DC to DC applications. And as already mentioned, M-CRPS power supplies have system monitoring and cybersecurity protection features, which again protects from unscrupulous bad actors or hackers looking to take down a system.
So, Ian, the Open Compute project governs M-CRPS, right? So, talk to me a bit about that.
Yes, that's right, Amelia. Open Compute, or OCP, is one of the main bodies organizing and defining the M-CRPS standards. Currently, the M-CRPS specification found on the OCP website is about 400 pages, if you can believe that. Multiple hyperscale and networking companies have built standard requirements from the governing application, from which a number of suppliers like Bell have built out product offering to support the masses.
So, Ian, what kind of central groups are we talking about for M-CRPS?
Yeah, major M-CRPS groups that we're seeing right now by product type and application include, but is not limited to, the narrow or 60 millimeter size. These M-CRPS products are more compact and usually cover lower power ranges like 1,000 watts to 1,800 watts. And then there's the wider group, which is more traditional, the 73.5 millimeter. This group of M-CRPS products are primarily used in higher power applications. Typical power output range from 2,000 watts up to 3.2 kilowatts. In this larger size, both 12-volt output and 54-volt output products are being developed. And next year, Bell will even be pushing this size up to 4,500 watts, which is really exciting.
Fantastic. Okay, so what kind of applications are we talking about for M-CRPS?
Key applications we are seeing for M-CRPS include obviously artificial intelligence, which includes machine learning, powering high performance GPU clusters and accelerators that require massive energy inputs, all with the titanium grade efficiency expectation. Also, the data center for compute and storage, used in enterprise servers and large scale storage arrays. Networking infrastructure providing redundant power for high speed switches and routers, very traditional. And last but not least, telecommunication supporting 5G infrastructure, remote radio units, and cellular based stations.
What kind of power supplies does Bell offer for these kinds of applications?
So, diving deep into the actual product that we're offering today is our TEM family of M-CRPS products. The TEM 1300, 1500, and 1800 are a family of M-CRPS AC to DC power factor corrected power supplies that are converting the standard AC power into DC to DC output of 12 volts. Typically used in powering intermediate bus architectures in the applications I've already mentioned. The TEM family of M-CRPS products meets international safety standards and displays the CE mark for the European Low Voltage Directive, and expected compliance for those using redundant power supplies of this nature.
So, walk me through some of the specific benefits of these kinds of power supplies.
Key features and benefits included in the TEM family of products: high efficiency up to 96%, as we've kind of mentioned before, offer a universal input voltage range from 90 to 264, obviously in their M-CRPS form factor, which everybody wants to see. They're hot plug capable, as we talked about already. Parallel options with active current sharing, which is very important. They have black box recorders, firmware security, which again ties back into that cybersecurity feature we're after. And last but not least, they're compliant with M-CRPS version 1.05.
So, Ian, what sets Bell apart from the rest of the pack when it comes to M-CRPS?
Thanks for asking, Amelia. What sets Bell apart from the rest is our complete range of products that covers almost all CRPS and M-CRPS power ranges up to 5,200 watts. Also setting Bel apart from the rest is our DC input offering of these CRPS and M-CRPS products that is a must for networking customer applications. Lastly, if a customer needs a modified or custom derivative for a unique application, Bel is best in class, offering R&D services to help with those types of problems.
So, as M-CRPS continues to evolve, what do you think will encourage the adoption of M-CRPS?
By adopting M-CRPS, designing engineers can right-size their power configurations, avoiding trapped capacity and significantly lower their total cost of ownership. As AI and networking workloads continue to grow, the standardization, efficient design of M-CRPS will be the backbone of reliable infrastructure. The TEM family offering is Bel's first release of M-CRPS. Bel Fuse, with its long-standing reputation for offering solutions for the networking community, sees this as a best first step in M-CRPS. Bel's roadmap beyond is full of the 73.5 millimeter products to address even higher power needs that the growing market is also demanding. This will include, again, both 12-volt and 54-volt options up to 5.2 kilowatts.
Fantastic. Well, Ian, I think that's all I have time for today. Thank you so much for joining me.
Thanks, Amelia. Really appreciate this opportunity today.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Bel. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EE Journal.